Introduction to Vector Algebra. Episode 1. In this episode, we are going to introduce you to the introduction of vector algebra. We are going to discuss the basics of vectors by looking into them from both mathematical and physical perspectives. We will also include examples to help you understand the whole image. We will go through these titles one by one, analyze them, and solve some examples related to them. And we will also show you how these titles are linked together to give the whole image of vector concept. We will use some simple animations to help you visualize these vectors, know them, and understand them. After going through this video, you will be able to solve simple vector-related problems in both physical and mathematical fields. Vectors are physical quantities that own both magnitude and direction. They simply represented by an arrow. Each of these arrows will have its own tail and head. Vector can be assigned a name, usually a letter, and this letter will be written with an underlying line to indicate that it's a vector quantity. The length of the arrow represents the magnitude of this vector, and is written with an absolute value. The slope of the arrow represents the direction of this vector, usually expressed by the angle that this arrow makes with some reference horizontal line. Vector can be moved to another locations, and it will not lose its quantity as long as its magnitude and direction do not change. This one cannot be considered the vector A anymore, as its direction has changed. And this cannot be considered the vector A anymore, as its magnitude changed, although its direction remains the same. When the vector is rotated 180 degrees, then it will be directed toward the opposite direction. In this case, it will be assigned a negative value. Now let's examine the vector magnitude. Let's consider the vector A with a magnitude of 1 meter. The length of the arrow represents a 1 meter of unit length. Now imagine that we add 3 versions of this vector. Then we will simply have a vector of 3 meters length. Notice how the 3 pieces will be added together and replaced by a new vector of triple length of the original ones. So the new vector will have a magnitude of 3, A. Now let's consider these 2 vectors. As you can see, we can define one of them in terms of the other one. So the length of the longer vector can be defined as twice the length of the shorter vector. Now look at this third vector. Now, C can be written as twice of B. And the negative sign indicates that this new vector goes in the opposite direction. C can also be represented in terms of A. And is clear that C is 4 times A. Let's move to talk about vector direction. And it's important to have our coordinates set up. Here we have the 4 directions of north, west, south and east. From now on, we will agree that any vector goes right will be directed toward east. And this vector will have 0 degrees angle. Any vector goes north will have 90 degrees angle. Notice that angles will be referred to the positive x-axis, which is the east direction. Vectors going toward left will be directed toward west. and will make 180 degrees angle. And finally we have south direction that makes 270 degrees angle. When vector goes exactly between north and east, we say that this vector is directed toward northeast, and it will make a 45 degrees angle. Same goes with northwest vectors, with a 135 degrees angle. Notice that the angle between northeast vectors and northwest vectors is 90 degrees, which is 135 minus 45. Now look at the southwest direction. Notice that it makes a 225 degrees. And finally southeast makes 315 degrees. Notice that these angles are always referred to the east direction. Now look at these three random vectors. Notice the difference in their amplitudes. The green vector is the shortest with 75 length, while the blue vector is the longest with 225 amplitude. Notice also how their angles define their directions. The red vector makes 25 degrees with the east direction, so it's located in the first quadrant. Notice also the directions of the green and blue vectors. Let's pay some extra interest to the blue vector. You can see it's making a 120 degrees with the east direction. We can also define this vector referred to the negative x-axis. So it means that this vector makes a 60 degrees with the west direction. It can also be referred to the north direction. And now it makes a 30 degrees with the north. So as you can see, you can refer your vector to any reference and find its angle.